let's talk about briefly about the history of soil science. So soil science, modern soil science begins around the 1880s in Western Europe and Russia, the old empire of Russia, right? So in Western Europe, the approach of this kind of science were more at the laboratory levels, where they start to make some tests in the chemistry of soils, because some of the soils in these countries of Western Europe was kind of degraded, and they were having some challenge to keep producing food to supply to their populations. But at the same time, in the old empire of Russia, it began, but with a field level approach, as well as in the United States lately. So in the first decade of the 20th centuries, after around 4 international scientific meetings, it's where the soil science got formalized, and it was by this time it was founded the International Soil Science Society in Rome, in Italy. The first meeting of those was in Stockholm, and then they moved to other countries of Europe. And because of the First World War II, they have some delays. But in the 20s, the soil science were get formalized, and it is when they emigrate to the United States, right? So around the 1924. So the soil science, we can say it is a really new science, because formally they has the science just has been developing for less than 100 years. Okay, so the father of this science, it's known as the father of the science, is this guy in the next slide in the picture. So this guy, the name is Basil Dukashev, and Dukashev was an erosion soil scientific. He is known as the father of soil science. So after this, soil science was really developed in the United States of America by a guy named the last name of this guy was let me okay, Marsbot. Marsbot, what he's done is it is that he translated from the Russian to the English the work of Dukashev and some of his students. And after this, soil science got really serious on the United States. So for this reason, many of the language in soil science that we use around the world, and the taxonomic system that many countries use is the one that was developed by the United States of America, especially by what the agency we know known today as Natural Resources Conservation Service, or NRCS. It is an agency from the USDA. So this is a little bit brief of the history. So let's get talking about what is soil, what is really the soil. So okay, so the soil. So when we talk the soil, sometimes we just think, as I said a few moments ago, just about the dirt. Other people think on soil, uh, relate soil because of the forest and other natural ecosystems. In our case, that many of us are linked to the food production or farming, so we think the soil in this way, but soil is much more than this. So other things that we extract from soil are the minery resources, right? So as we can see in the next slide, there is a mine in soil that we extract. So many of the mineral that we use in many of the gadgets we use daily, as our cell phones, uh, a lot of other things, right? And the soil, it is the foundation or for uh, building sites, right? So the civil engineers look the soil for the strength and the capacity to hold structures, differently from the agronomists or the soil scientists. Soil scientists also are known as edaphologists or pedologists, are the same things. They are soil scientists, right? And for the agricultural purposes, as we're gonna be talking now, so for the agricultural purposes, what we study about the soil are the first 2 meters or the first 6.5 feet. Okay, so that's the area that the edaphologists or pedologists or soil scientists make their research to determine the capacity of the soil for farming and hold an agricultural operation. Okay, so by the way, feel free to make any question at the bottom of your screen. You will be seeing the Q&A icon, so just push there and use this chat for any question that you have. Okay, so in which way we define soil? Soil is a natural body comprised of solids. Solids are in soils are mineral and organic matter. We will be talking in a little while about this. Liquid gases that occurs on the land surface, occupies space and characterized by one or both of the following horizons or layers that are distinguishable from the initial material as a result of addition, losses, transfers, and transformations of energy and matter, or the ability to support rooted plants in the natural environment. That's it. This is the definition that NRCS used, but as a funny fact, for in some way, up to date, the soil scientists keep having some discussion about to adopt an official soil definition. But for our purpose, we will be using the USD NRCS definition. Okay, so I know it is a lot of technical terms in that definitions, but we will be break down each of them in the next slides. When we are studying the soil for farming purposes, these first 2 meters or 6.5 feet, when we make this cut to study this, it is named or known as a soil profile. And what is a soil profile are the layers that appears within this deep in the soil. So in ideal soil, we gonna find around 4 layers, and in the very bottom we will find the bedrock or the mother rock, as some people call it. Okay, so the first and we make the differentiation of the each layer or horizon of the soil because of its texture, the color, the presence of the roots, the presence of some soil living animals and things like this. Okay, that's the reason that's the layer are formed. But as you can see, not all as you will see in the next slides, not all the soils look like this one. It is, this is an ideal soil, like the one in the next slide that you can see it. So Pam, please switch from the slide and see this model of soils that we got in there. Yeah, there you can see and a profile of soil. Uh, this one, it is not 2 meters deep, but it's around 5, if I remember well. As there you can see the different layers of the soils. At the top of the soil, the topsoil, that's its name, the horizon A. Then we have the horizon B, then the C, and then we have the bedrock or the R horizon. It's named two, but not all the soils look like this. So let's see the next pictures that you can see the what kind of funky the soil can have sometimes. So in the at your left side of the screen, at the upper in the upper picture, it is a soil that is not so deep, that you can find this material, parental material or rock, within the first 12 or 30 centimeters of the 12 inches or 30 centimeters of the soil, and it is commonly happen. And I know we have some guests from Bahamas, and up to I know and what I can see about the soils in Bahamas, that tends to happen there. So at the bottom part of the left part of your screen, you can see a soil that looks like like an paint or something like this. Looks really pretty, right? But you have the horizon mixes along the profile of the soils, and that will happen too. It is normal. And the big picture at the right part of the slide, you can see a soil that don't have many differentiation within the first 6 feet feet of depth, right, of the soil profile. So there are many soils that are really deep, and no matter how deep you go, you probably don't see many differentiation within this, but those tends to happen more in plain areas with many years of development of that soil. Okay, so it is just for you to have an idea of what is of how soil profile looks. Okay, so there are plenty of different kind of soils that you will see it in this presentation too. So the soil, it is a really important thing for us. Okay, so some of the functions of the soils are the foundations for building. It's they regulate the flow, the cycle of nutrients. They provide us with some of our pharmaceutical and medicine materials, as you know, as the penicillin that it's produced by a soil-borne fungus, right? So the soil provide a lot of services, and when I talking about the soil, I just say a few things to the people to understand. So you know, in the Genesis, in the Christian Bible, so they are the story that the God takes a bunch of clay and mold the Adam, right? So what is believed is that this story have the roots in the Asian beliefs in other cultures, that they saw the soil and the sun as the mother or fathers of the creations, and the name Adam, it's really alike of the Hebrew word for soil. Okay, so that's some of the factors in the human history about the importance of the soil. Pam, so I think we have a kind of problem with the presentation. Sorry. Okay, there we go. So, but for the purposes of agriculture and our daily life and environment, some of the soil ecological services are that the soil keep the water and the air clean. I'm not meaning that any of those resources are uh, have more importance one from the other, but the soil plays a key role to maintaining the water and the air clean. Okay, so it provides space for forests, wetlands, and other ecosystem. Fauna and flora diversity, a quarter of the fauna and flora diversity of biodiversity of the worlds, it's on it is on the soil, right? And what is really important for us, it provides farmlands, right? Without this, we can survive, you know. Okay, so let's see other things about the soil science basics. Okay, well, if as you see here at the left picture, it is a picture of bare soil eroded by wind, and this caused this kind of dust storms. Or if you look back in the history of the, for example, of the United States of America, it was really common when the western part of the country was getting exploded, that it happens the dust boils, right? And those are storm of soils that happen in continental areas. So the quality of air, it's really affected by the management of the soil, right? So in other parts, other thing that for water quality are when we have some erosion of the soils and runoff water that brings sediments to the body of waters. And sometimes, or major part of the times, those sediments are loaded with nutrients, which cause blooms of microalgae and other aquatic plants that cause a lack of oxygen in the water, bringing down the quality of water, and sometimes they really affect our daily life, because if this is your friend of water from consumption, so it can have a really big problems, right? At the same, We need to remember, no matter where you are, how far from the coast you are, everything that you do with your soils will, in some way or another, will affect the ocean ecosystems, especially when we are on the island. So we are very, very prone to affect for some example, the ecosystem of the coral reefs. Okay, so that's one of the important things to start to manage our soil in a right way. Okay, so Pam, let's go ahead. Okay, now we're gonna be talking about how the soils get formed. Okay, so they are soil formation factors. There are five, and to the form get developed, it takes those factors to have an integration and an interaction among them. Okay, and those factors are climate, organisms, topography, parental material, and time. So climate, the soils, for saying in some way, the soils in the tropics tends to develop faster than the soils in temperate areas, right? Because in the tropics we have summer year round, and all the process keep running. So that's the reason why soils get developed really fast in the tropics compared to the temperate areas, right? Organisms, so soils, when we was talking in the soil definition about the solid part of the soil, uh, plus the material aside of the mineral part of the soil, we have the organic part. So the organisms in the place that the soil is getting development have a direct impact in the quality or and the characteristics of those soils. For example, if we are in an area where we have a lot of pines in comparison with a broadleaf forest, so the soil will have a really different characteristic, especially in the chemical characteristic, for saying some way. Okay, so that's it's one of example how the organisms affect the soils, not just the microorganisms living in the soil, but also the plants and the animals in the area. So the topography, it is really important for the soil development in places where like in here in Puerto Rico, that we have major part uh, uh, of our island, it's on hills, right? So soils on hill slopes tend to develop uh, less if you see it, because they are having constant wash of all the material because of the erosion, because of the rain, and and the slope. Okay, so in the other hand, soils in the plain areas keep are turned to be more fertile because they are receiving all that input from the mountains, and they are stable, and they can develop uh, more, and you can find in the plain areas more developed soils with rich in organic matter, and more deep in some cases, because they are stable all the time. Okay, the other thing is parental material or bedrock. When we are talking about the parental material of the soil, we are talking about the rock that it's going to get disintegrated, the right term for this for this event, when the rock is getting disintegrated in soil science, is weathering. The weathering, it is because of sorry, my bad. Okay, so the soil, the rock, it's getting weathering because of the climate, the organisms, another factor that it will be getting disintegrated, and the soils, most part of the soils are just a disintegrated rock. But the soil, if you see soil, could be classified and renewable resource, but for our lifespan, the soils, we need to manage the soil as they are finite resource, right? Because all of this takes a lot of time, hundreds or thousands of years to soil to get developed, right? So soils are in constant cycling, but for our lifespan, we never see these changes in soil. That's the reason why we need to manage the soil in a better way. Okay, and that is the matter or the role of time in the soil. Okay, so those are the 5 factors of soil formation, and they are combined with the 4 soil formation processes. Those are those processes are addition, losses, transformations, and translocation. When we are talking about the additions, we are talking about the organisms, the other material that could be bring for because for erosion, because of flooding of the areas, the path of rivers in some time, um, this kind of events. Those are the additions. So losses are when soil have losses could be in the surface because of the runoff or through the soil profile that sometimes we call this lixiviation for same it's one of the terms that we use when we lose some material through the soil profile. At same, the additions could be happening from the bottom to the upper part of the soil, sometimes by capillarity. That tends to happen when we have soils uh, above of some salty water reservoirs. We sometimes we can have this kind of event, and that's for farm purposes. It's not good for this because salt really affect the development of roots of the plants, and so this is one of for some example of what is additions or and losses, right? Transformation, we are referring in the transformation, an example of this is the decay of organic matter in the soil. Also, with the pass of the time and the weathering process, some of the minerals in the soils will change from one mineral to form another minerals and combine sometimes with other ones to form another ones, and in this way, right? And translocation are the pass through the soil profile of some of its components from the bottom part to the lower parts. Uh, that is one of example from translocation, right? So after saying all of these of the soil formations, so all of these have give us the basis to start to classify the soil and study and classify the soils. Soil taxonomy or classification was developed in the United States in around, if I remember well, in the 40s, I think, or 50s. I don't remember the exactly date, but the guy that started doing this was a scientific working for the agency for NRCS uh, of the USDA, and he's the one in charge of develop the taxonomy of the soils. That's the reason why uh, the most used system of classification of soils around the world is the one developed from USDA. But if you research on the on online, you can find that the Food and Agriculture Organization from the United Nations have a classification system. In Brazil, they have another classification system. In other parts of the other countries have their own classifications. But no matter which of those systems you are using, all the time we're going to have 12 soil orders in the entire world. What exists just 12 types or 12 orders of soils. In terms of classification, soil of orders are the very upper level of classifications, okay? And the most specific level of classifications of soils are the series. Series, it is the soil that was discovered in X part of the word, and they name it sometimes tends to have the name of the part that were discovered by the first time, and it is the more specific term to refer and identify this soil. Okay, within those levels we have the other ones, suborder, great group, subgroup, family, but for uh, for daily purposes, for saying in some way, those level of classifications are you will not use it many much. Those are more the name that you give to the soils under this level of classifications are more for use of scientific purposes, right? So you will find the names of the nouns on under those level of classifications. They are compound nouns, and each part of the noun give you some information about the soil, as the weather regime, the precipitation regime, if they have a particular characteristic within the horizons, and the order of the soil that you are dealing with it. But for purposes of us, that just I want to you to know that the most specific and most useful level of classification for soil are the series and the orders. Okay, so let's break down the soil of or the order of soils. Okay, so the 12 soil orders around in the world, they are the alphisols, andisols, aridisols, antisols, gelisols, histosols, inceptisols, mollisols, oxysols, spodosols, ultisols, vertisols, anoles, and inoles, right, for soils. And each of them have a specific characteristic. Okay, let's take, for example, the andisols are soils derived for recently volcanic activity. That's mean the most part of those soils you can find it around what we call the ring of fires. That's the coast that border the Pacific Ocean, and in the islands within the Pacific Ocean, as Hawaii, for bring some example, or in the case for related more to our daily, in the area that we are working and running this program in Guatemala, one of the most common soil orders are the andisols. Okay, but uh, not in Bahamas, neither in Puerto Rico, neither in USBI, we have andisols. Okay, uh, other other sales orders that they you can find in our islands or are commonly finds are the mollisols. Mollisols are one of the it is the best soil order with the natural characteristic for farming. It's the a natural soil that have all the qualities that you want in a soil to farming, but because of natural occurrence. Okay, uh, for describe some soil, and all the time I ask the people a question. So what is the best soil for farming? And many times people answer me molly soils, and I say, it is good, but it is because of the natural characteristic. But the best soil to farming, it is the one that you have on your farm. No matter what, that's the best one. They are not bad soils for farming. They are soils that are not managed in the right way. Okay. So at the second part of this presentation, we will be talking about practices to be implemented in your farm to improve your soil quality. Okay. So let's see what kind of soils we have in Bahamas and USBI. Okay, so I was making some research for this presentation, and I could not find, this is, by the way, it is an invitation for any of Bahamas that have more information or within our of the people in this webinar, they are anyone related to work with any government agency there. I invite them to let's talk about a little bit more about soil classification, because I could not find any map of soil classification from Bahamas. No matter, I found some information of some research done in Bahamian soils, and we will be sharing some of this information with the guest at this webinar, right? Pamela will be sending this presentation with some support material of soil, including the information that we found from Bahamas. But reading about it of this and using some of my expertise or knowledge of soils, I can say that it's really probably that the predominant or the most common soil in Bahamas are molly soils, but with a little, molly soils with not so much development, because I know, because I talk with some farmers there of our network. So the soils sometimes tends to not be so deep soils, right? And this picture is from a this this picture is from a piece of soils from Bahamas, and as you can see, this soil looks dark. The soil looks dark, and it is, up to I understand about it. I think this soil, it's really fertile for farming, right? No matter if have some presence of rocks, and I know that sometimes it's kind of challenging to tillage, but these soils, I think they have a really good natural characteristics, right? The other soil that you can find in Bahamas, uh, in this picture, is from a pineapple production in island. I forgot the name of the island. I think it was um okay, my bad. I forgot the name of the island, but it is not it is not Abaco, Grand Bahamas, or Nassau. Okay, so sometimes that's other kind of soil that you can find there are kind of reddish soil. These soils sometimes tends to be a kind of acidic soils, but because of the bedrock or rock that you can find in Bahamas, they tend to have a pH neutral near to 7, so they are good soils too. And the formation of these reddish soils, it's kind of different. They are not happening by the same way of the other ones, right? So the reason that the Bahamas have those kind, okay, yeah, some pineapples came from Eleuthera. Okay, my bad with the pronunciation. Okay, so my main language is Spanish, so I'm trying to do my best with the English. So right, it's what I find on online and with information, and I know that this island have a history of pineapple production. And okay, to explain a little bit more, so what could happen with those soils is it is because when the plagues, the tectonic plagues, were moving and the continent was getting separated along the development of the earth. uh, Sometimes the when they got separated, they migrate from one part of the world to others, and maybe this part of this island was over the sea level, and they have some encounter with the other part of the island. That's one of my theories because what I was reading about it. Okay, so the rock in talking about the parental material or the rocks, that they are one of the factors of soil formation. Many of or the major part of the Bahamas archipelago, it is the limestone rock, right? And this picture, it's from a national park in Nassau, and it's what the limestone looks. The limestones occur because many of the island in the Caribbean was produced by the volcanic eruptions under the sea levels, and they rise up. And this material came from the decomposition of many marine animals, and that's the reason why what is common to find some fossils among those rocks. Okay, but I'm kind of excited to go to Bahamas when COVID get better and learn more of the farming there and see the soil there. But by now, what I can say it is that the soil just need a little bit of, as the way I say, of love to produce really well. They have a lot of good characteristic to produce. Okay, so let's see what we got on USBI. In USBI, we have those maps because USBI, as well as Puerto Rico, we are territories from USA, and the NRCS work in our region, right? And the office from NRCS of the Caribbean area is located in Puerto Rico. So we share the same team from NRCS, right? So there we can find out of the 12 soils orders, we can find six of them, right? But the most predominant one are this one that is named mollysols. And when I went to Sand Creeks to visit some farm, I was using an application that we can use in Puerto Rico, Virgin Island, and United States, that say to us which kind of soil we have. If the soil was in the if the soil it is in the database from NRCS, using this application, we can know which kind of soil we have. And the farms that I visit there, all of them, maybe except two farms, uh, are mollysols that they have there, right? So this is the series that we can find there. For example, in Puerto Rico, out of the 12 soil orders, we have 10 of them. The only one that we don't have are the andisols, because we don't have volcanic activity, and the jelly salts. And the jelly salts are really, really important for because they regulate many much the storage or of greenhouse gases emission to the atmospheres. But the jelly salts are soils that all the time, no matter which season we are, they keep a horizon or a layer of ice within the soil profile. That's the reason that neither in Puerto Rico, USBI, or Bahamas, we have this kind of soil. Okay. So well, after this brief or an intense part of soil science basics terms and information, we're going to move to talk about the adequate soil management. And by the way, I just want to stop here and ask if anyone have a question about it, what the terms we was talking about it. And just to say, I know these webinars are wants to provide the tools for better implement better management practice at farm level. But for me, it is important for all of you to know those concepts, because the good agriculture, it is not a recipe. It is a base of knowledge that you can apply and help you to analyze everything that you are doing as a farmer. Okay, that's the reason why I'm explaining those basic topics of soil science. Okay. Let me see the chat or the Q&A if we have.
So at this point, I
Uh,
don't think we have any open questions.
okay,
Juarez,
great.
just a couple comments and people sharing information and feedback. Thank you all so much for all of that. Um, we have a comment that says for USBI, in Puerto Rico, the USDA and RCS, that's the Natural Resource Conservation Service, has a free
Mhm.
website where you can look up your farm on a map and see the soil types. So yes,
Yep,
it's
it's
called
named
the Web Soil Survey. We can actually share the link. I'll be
yep.
sharing it in the.
Yeah,
Thank
and
you.
by the way, the application that I was mentioned is linked with this web page. So it's a version for this web page to have it in your mobile, right?
Yeah, an
Okay,
app.
well, let's move forward. And yeah, so
Mhm.
let's move forward, and let's talk about the adequate soil management. By the way, I just want to mention that I will be sharing some practices, some basic practices, but there are many, many other things that you can do to improve your soil management. Okay. Uh, Pam, I think we get out of the. Okay, let's talk about soil quality or soil fertility. Okay. The soil quality is defined as the ability of the soil to function as an entity capable of sustaining an ecosystem, on understand plants, or support plant growing, animal, and us humans. Okay. let's break down this. If you if you read about soil fertility, or as for example, for me, I'm an agronomist, so at the in the in the faculty, what sometimes, or many much time, or the approach of many of soil scientists, when we talk about the soil fertility or quality, it just focus on the chemical properties of the soils. That's happened because of the industrial agriculture practices adopted or and promoted widely after the Green Revolution. So if you were in the first webinar we did about the sustainable agriculture series past month, I talk a little bit about what is the Green Revolution, and I invite all of you to search for what it is. That's the reason that we our agriculture sometimes have some practices that are really affecting the environment worldwide, right? But that's the reason we're here to improve those practices. But when we are talking about soil quality and soil fertility, we need to have an holistic approach, an integral approach to evaluate this. An integral approach to determine how good is your soil. You need to evaluate three basic characteristics of soils. They are the chemical properties of soils, physical properties of soils, and biological characteristic of soils. Okay, so let's talk of each one, and I will tell you the way you can know those characteristics on your soils. Okay, first let's talk about the chemical properties of soils. So when we are talking about the chemical properties of soils, we are talking about the minerals that we have on the soils, or the nutrients. We are talking about the pH, or the acidity of the soil. We are talking about the percentage of organic material that you have, matter that you have in soils, right? So the best way and the more accessible way to make this is to send a sample of soil to a laboratory to analyze this. So in USBI and Bahamas, they are it is kind of simple to do this, and it is not so expensive. So I invite all of you, if you have the opportunity to make some soil tests on your farm, to make it. Okay, so when we send the email with the presentation and the information, we will be sending some contacts of laboratories that you can make this kind of test on your soil, right? If you see there, this image is a report from a soil test from one of our uh, participants in Puerto Rico. If you see there, this is what it's called in soil fertility as a basic soil fertility analysis. Okay, so there you will find the basic cations as sodium, potassium, phosphorus, uh, some micronutrients have molybdenum, boron, and things like this, that they are really important for the well growing of the plants. If you look at the far right column of this paper, you will see that it says that CEC. That means the cation exchange capacity of the soils. And let's stop this and explain this slowly. What is cation exchange capacity? Is the capacity that the soil have to exchange cations, nutrients with the plants. Because when you put a fertilizer to the soil, the fertilizer is not providing the soil directly with the nutrients. The one that have the capacity to make this is the soil. That's the reason that you need to have your soil working in the best way at the maximum capacity to make the soil to provide all those nutrients to the plants, right? Uh, for example, another example of this: if the pH of the soil are not the right one, many times that cause a fixation of the phosphorus in soil. So that's a reason why we need to manage the soil in a holistic way to make the soils work uh, in our favor, right? To provide the plants with all of this. So those are some of those basic characteristics of soils, right? So if you are interested in make this kind of chemical test of your soil, you can contact us and we will be so glad to help you to figure out and help you with to figure out and have this done. Okay, so we are not saying that we will be paying for this, but we will say that we help with the contacts, and as well I can make the arrangement of the soil sampling in the farm, because it is important to take those samples in the right way, because the analysis, if you don't take the samples in the right way, the analysis can show some fake results, you know. And other important things of make this, it is that in terms of operation cost, it's normal that the people that use soil analysis they can lower their production cost, because they know how much of fertilizer you will use, right? If you are using synthetic fertilizer, it is really recommended, highly recommended, to make those kind of tests. Other thing it is that uh, as I mentioned yesterday in the Spanish section, I'm not saying I'm not talking about in general terms, but sometimes the companies that sell fertilizer, they provide this service for free. But it is important to you to know that you need to be a little bit aware of the sometimes those companies sometimes they just want to sell the fertilizer, right? And sometimes they not make the right recommendations. Okay, I'm not saying everyone are doing this. I'm just saying that in my experience as agronomist, I saw this sometimes. Okay, so just to let you know and for you to be aware when you are if you have to deal with it. Okay, other properties of soil that are really important are, as I mentioned before, are the physical properties. And the physical properties in terms of soil science, they are many, many, many much, and it is a huge field of this. But for farm purposes and in terms that you can deal with it in farm. So let's talk about the texture of the soil. When we are talking about physical properties, the first thing that we need to measure and know it's the property, the texture of the soil. Okay, so what we define as soil for agricultural purposes are any particle that you have that measure less than 2 millimeters of that diameter, right? So it's the at the picture that you have on your right of your left part of the screen, you can see the difference of size of the three particles of soils. Those three particles are sand, silt, and clay. Okay, being the big one, as you see there, the sand, then we have the silt, and then we have the clay, and you barely see the clay because the clays are so small that they are not visible to the human eye. You need a microscope to see the clays, but no matter the size, the clays are the most active particle of the soils. Clays determine a lot of the soil behavior, right? And they are the one responsible for the cation exchange with the plants. Okay, so the clays are the active part of the soils. Sands have some mechanics role in on soils as well as silt. Silt plus mechanical properties in the soils, they can hold a little bit of water, but the water retention in the soils also happen because of the silts. Okay, so at the right part of the screen, you see there a texture triangle of soil, right? So you see the numbers in any of the axis of the triangle, right? So in each of them, you have one of those particles at the right, at the left axis going from the bottom to the upper part of the triangle, you have the clay. At the other part, at the right side, you have the silt, and in the bottom axis you have the sand. And how it's work, when you done an analysis for texture at the laboratory level, so they will inform you that you have X% of sand, X% of silt, and X% of clay. You go there with each of these for make an example. If you have a soil that have 40% of clay, you identify the clay axis there and the lines running in the same way of the arrow that you see there. That's it's the way that you will identify your texture class of your soil. Then, if that soil have 20% of sand, you will look in the line that's going from the right to the left, over to down part of the triangle, that line, okay? And if you have 40% of clay, 20% of silt, you need to have 20% of sands, right? So you go to the triangle and identify the line that's going from the very bottom to the left upper part of the triangle, right? And you go there and say, okay, we have 40% of this, 20% of that, and 20% of sand that is running from one side to the other. And what we got, it is, okay, let me see. Okay, so what we got, it is a soil that could be classified to clay loam. That's the texture class of the soil, right? For saying in some way. So when you see the term loam in the texture part of the soil, loam refers to a soil that it is well balanced within the three particles. Okay, the distribution of the particles are well balanced within the soil. Okay, that's why the term loam is. Okay, so but let's talk about how you can do it this at your farm, or or make by your own, do it by yourself at your home, or your farm. Okay, so let's see. The first one of those tests are the yard test, or the mason yard test. This test work really well, except in soils that tends to be more acidic soils, because okay, let me first explain the procedure of this test. As well, we will send in the support material, we will send the instruction for you to do this kind of test. So the mason jar test, what you do, it is that you take around the half volume of the jar. uh, Even you can make this. You don't need a mason jar to make it. You can do it using any kind of glass or plastic uh, bottle, okay, that you can make it as well, using this kind of materials, right? So you will put the half of the volume of that jar with this. You will fill it with the soil. So you as well. Maybe let me explain this. So when we are taking samples to run any test of soils for agricultural purposes, commonly we do it within the first 12 inches or 30 centimeters of the soils, because of the agricultural purposes. So within this depth, it is where we find the active roots of the crops of the plants. The active roots of the plants that are responsible to acquire nutrients in the soils. They commonly they are they you can find it at that depth. After this, if you find other more roots of the plants after the 12 inches, sometimes those roots are just for purposes of water intake and help with the strength of the plants, right? So that's the reason why we make all the soil samples we take for these purposes within the first 12 inches or 30 centimeters of the soil. So you will take uh, an sample of your soil within this depth, fill the yard at the half, and then you fill fill the volume with the jar with water, and you will shake heavily to mix all of this with water, and you just left the yard in a place, in a safe place, for around 24 hours. After this, you will see that the soil inside the yard will precipitate, as you can see at the right uh, picture of your screen, right? So, and then you see that there are three fractions of soils. So the first one that going to be precipitated, and I can say that will happen within the first seconds, or less than a minute. Then after you shake it, are the sand. The second fractions of this precipitation will be the silt, and the upper part of this will be the clay. Okay, so because of this, if you want to know the percentage, it is this, what you do is that with a scale, you go there and you measure the height of the column of that of those particles, and then you divide by the total of of the height of this column. Each part of this, you divide the measurement of each of those layers by the total height of the column, and in this way you can have an idea of how those particles of soils are distributed in your farm, right? But as I mentioned, for soils that tends to be more acidic soils, and let me explain again of this, soils with colors with reddish and yellowish colors tend to be more acidic soils. The color in the soils are not directly related to the level of acidity of the soils, but in the major part of the times, it's happened. Soils that tends to be more reddish and yellowish tends to be more acidic, and in the other hand, soils with darker colors tend to have a higher pH and be less acidic soils. Okay, uh, why they don't work well in acidic soils? Because the oxides that's happen in this kind of soils tend to glue all the particles, and the particles precipitated in the water because of the size, and you can have those oxidized oxides um, gluing the a huge amount of seals, and the seals can precipitate and looks like they are sand, but they are not sand, they are silt, right? Because of this, I recommend is, and it is my favorite one, the next method. It's named the field method, okay, or the hand method as well. You can find it on online as this, okay. So Pam, let's go with the other slide, please. Okay, the field test. There, as you see, you will do it by your hand, and what you need to do is just take the amount of soil you can put inside your hand. You will wet the soil as much as possible, and then you start to play with that dirt, with that soil, okay? And then you start to try to form a ribbon. If the ribbon form, it is that your soil have a well balanced particle proportion, right? But then you start to squeeze that ribbon and try to make it longer. If this happen, your soil have a huge amount of clays. But if the ribbon form, but you cannot make it longer, and the ribbon break, that means that the soil is well balanced. If your soil is really sandy, you even can't could not form the ribbon, okay? But if you see that diagram was developed by USDA, and we will send you, if you want to make this test, you just go step by step of this diagram, and that will give you a good idea of what's the texture of your soil, okay? Why this is important for our practice in soil? Because of the texture of the soils, that's determine how heavily you need to plow the soil, to prepare that soil. As well, that will give information to us about the drainage of the soil, about the water retention of the soil, right? That's it's the reason that I highly recommend to you to know the texture of your soil. That will determine will be determine some important issues about your soil. About one of these issues are the irrigation. The irrigation, as all of you know, agriculture have a highly consumption of water, and water each time get more important because one of the effects of the climate change is the shortage of water, right? So we need to manage water as best as we can. So knowing your texture of soil will determine or help you to figure out the best way to manage soils and provide irrigation to your crops. Okay, that's one of the factors that it is important to know that the texture of soil. Okay, so let's go ahead with the other one, Pam, and now we will talking about the biological properties. And by the way, in the industrial or conventional agriculture, as we name it, uh, soil fertility is really focused on chemical properties, but also some of the physical properties of the soil because of water management of the soils, but ignore completely the biological component of the soils. And the soils are a living entities, right? Soil are alive, okay? Um, and for agriculture purposes, it is really important to maintain alive those soils. Soils that are running in the best way, they have a lot of microorganisms working there, and we can make those microorganisms help us to farming. Okay, believe me, I will explain a little bit more. So some of the physical of the functions of the soil microorganisms are they are primary agents in the nutrient cycles. So this is related in the farm. We can relate this with the nutritions and fertility of the plants. So they regulate the dynamics of soil organic matters, right? So microorganisms in soils are responsible to decomposition of the organic matter, and when they are decomposing this organic matter as well, they are release nutrients for the plants to be taken by the plants. Okay, so the soils and the microorganisms in the soils, they help to sequestrate organic carbon and other greenhouses. By the way, I don't remember if I mentioned it, but one of the other important roles of their soils, it is the soil is one of the major storage of carbon and other greenhouse gases. That's another reason why we need to manage the soil. So when we destroy the soil and we manage in the wrong way, we are we are putting those gases back to the atmospheres, and we don't want to keep doing this, right? So as well, the microorganisms in the soils have the power to modify the physical structure of the soil, and as a consequence, the water retention. And as I mentioned, those organisms can improve the acquisitions of nutrients by the plants and keep their healthy. Okay, let me explain this. So, mo- a good part of the pest and the disease that affects our plants, our crops, are soil borne. If you have a well developed soil with that it is alive and have a healthy microflora, so the space for those soil borne pests and sorry, my bad, I forgot, and disease for the plants, it's limited, right? When we have this, we are uh, for saying some way, we are making more sure our environment for plants to be healthier, right? So if you look in the literature, or you know by now all of these in the present, we have a powerful tool that is in the internet, right? If you Google what is suppressive soils, you will find it is a kind of practice that some farmers do to develop their soils to be so healthy, and the microorganisms are so developed that they suppress any pathogen that it is within the soil. Okay. So let me see here. This is soil microorganisms can also help bioremediate against harmful chemicals. Oh yeah, for sure. That is another. Thank you, Christina. This is true. Other role of the microorganisms is that they help to decompose any harmful substance in soils. Okay. So that is, for example, I have a friend that she's been researching from soil bacteria that decompose products made by using from oil products, right? And it's named bioremediation. That's the term for this kind of work, right? Okay, so let's talk about a little bit of microorganisms and other important factors in the soil. Okay, so now other thing that well, first, as I was telling, so the soil have many life inside. So it is estimated that in a spoon of healthy soils are more organisms that people in the entire planet. Okay, so that is how important it's to keep alive the soil. And as I mentioned at the beginning of the presentation, the soil hosts a quarter of our planet biodiversity, and many of that biodiversity relies of soil microorganisms. Okay, so directly linked to the life in the soils are one key factor that I always uh, promote, and it is the organic matter. So let's talk about the organic matter, okay? Organic matter in the soil are really important. As making a pause here, as I always mention to everybody, to every farmer, or every time I have the opportunity, it is that the uh, key for a successful agriculture and a healthy environment are the soils. But within the soil, the keystone in the soils, it is organic matter. Organic matter, it is magic, okay? Believe me. Uh, so let's see what is organic matter and in which way we can provide our soil with the right amount of organic matter. Okay, so the organic matter are the remains of decomposed organisms, plants, and animals. This decomposition process is mostly carried out by the microorganisms that naturally inhabit in the soils. Soils dwelling animals such as worms and insects and other invertebrates also participated. But the decomposition of organic matter, the biggest part of this, was carried out by the microorganisms in the soils. When I talk about microorganisms, I'm not just talking about bacteria. We are talking about fungus, actinomycetes, and other kind of microorganisms that live in the soils, okay? So the humus originate from this process. And let's see what is humus. The humus, when we are talking about the humus, we are not talking about the food that I like really too much with when we are talking about the organic matter that it is in the maximum state of decomposition. And I put there quote unquote because this humus will keep uh, the process of decomposition in the soils and form other substance in the long run of the time in the soil. But for our purposes of this presentation, what you want to know are the humus. It is an state of organic matter that you cannot identify where the material came from, okay? And I exaggerate to say in some way, but just to give you an idea, we could not say that organic matter came from a branch of a tree or from an arm of a human, because we are organic beings too, right? So uh, that's a reason that is what is humus. So at this point, you have the organic matter in the right decomposition state to apply to the soils. And other thing I always say, or for example, to let the people understand, it is so prior to a few years ago, I worked for around, I think around 4 years as independent consultant. And sometimes when I visit some farms to make some consultations, they say, "Man, I'm applying compost to the soils, but we have problems. The plants were not growing well." When I was going to check, I discovered that they were not applying compost or humus. They were applying chipped wood for saving some, for example. And when you do this, you are causing problems to the soils, because the soil microorganisms will use the nitrogen in the soil. They will sequestrate this nitrogen to process the carbon in the organic matter, causing a shortage of nitrogen for the plants. That's the reason why when we are using the humus and applying compost or any other kind of organic matter in farming, we need to be sure that the decomposition is in this state to don't cause problems in the soils. Okay, so that is humus, and now we will see some practices of what in which way we can produce this humus, right? So the very simple one or most popular one are the compost, and the composting process will help us. It is an ally in the farming, right? So what is the compost? The compost is a product of the process by which organic waste is decomposed by the action of microorganisms and other natural organisms in an aerobic way. It is a process that recycles nutrients and provided life to the soils. In this way, we take advantage of materials that would otherwise become waste, right? And they are not. I forgot to put column, quote unquote, this waste, but we call it waste, but it is not waste. They are not debris. They are really helpful material that we can reuse in our operation, right? As I say, compost is not a fertilizer. It is a real super fertilizer, because have the power to provide our plant not just nutrients, but we help us to develop really well our soils. And other thing that's the compost help it is with the water retention too. Okay. So let's see what consideration you need to have to make a compost on farm. Okay. By the way, we will send a kind of recipe for make compost, but the best way to make compost is the one that works for you. Being a farmer takes a lot of time. I know it is a hard work, and sometimes we need to figure out the way to make the things as best for our time. Okay, so what I'm referring it is um, don't overwhelm yourself to have a compost really, really, as you read all the time. So compost, you can make compost in a really easy way. Okay, but some of the consideration that we need to have to place the compost in our farm and start to produce compost, as well as you have a garden, you can use it too. Okay, it is the location. The place should not have excessive humidity or shade. The area where it is or will be located must have a good drainage. It is ideal to have a direct light of approximately 6 hours a day, close to a water source, should not stand in the passage of a run of water, and different types of as well as different types of containers could be used. So I just include that last bullet, because if you are just doing a small amount of compost, you can use containers. You don't need a huge uh, part of your land to produce compost. But if you are doing in a larger scale to provide you enough material for your operation, well, the best way is make it by doing piles, as we will see in the next slide. Okay, why the place should not have excessive humidity? Because a lot of humidity in the compost will cause that the compost pile don't reach the temperature, right? And to complete the process of composting, so it relies on those temperatures to rise above the 100 degrees. Okay, so we will see some of those specific criteria in a few moments. Okay, um, the area. Other thing is the close to water source, because if you are in having or passing by a dry season, you need to add some water and humidity to the soil, to the compost, to rise the temperature, right? That's the humidity, the adequate humidity on the compost pile is a key, play a key component to done this process in the right way. Okay, so let's see a short recipe of composting. Okay, in those things, I think I will change the title of this slide. My bad, I forget to do it. But some of considerations or specific things that you need to ensure to done your composting process well, it is a constant humidity, as I was explaining, uh, to optimize the process, and how you can test your piles have the right amount of water. So as I say there, so when squeezing the material into the compost pile, their moist should feel like a sponge after being run out. Okay, so in the way you can, you go as far as you can go to the center of the pile of compost, you grab a bunch of that material and then put it down and squeeze. When you squeeze this material, if has have a lot of water squeezing off there, you have too much water and high humidity, and that will cause that your compost pile will not reach the right temperatures. But if you squeeze this and it's leave a little film of water in your hand, that's the right way to determine you have the right moisture on your compost as well. This criteria you can use it to determine the right humidity on your soil. The temperature should be reached between 140 to 160 Fahrenheit degrees for not less than 7 days. For what? Because that's the way we ensure that all the pathogens and the seeds presence in that material will be destroyed. Okay, so with this temperature, that is what make our compost pathogen and pathogen seeds and all and any other component that could be harmful for our health or the health of our farm, that's secure that this compost will be safe to the use it and the management. Okay, the compost can be turned over as this speed of the okay, you can turn the piles of the compost, and that will speed the process because you are putting let the pile to have more air as well. If you don't have the time of it is too much work for you to turn over the piles, I will send in the email. We will send a model of static piles, composting in static piles that you can make it, and you just need to get some of PVC pipes and drill some holes along of the pipe and put it within crossing the pile, and that will help to maintain air running through the pile. Okay, and that will help to speed up the process. And the last thing I want to share with you about the compost, it is that the composting process can take from 1 to 10 months and even could take more. So that's the reason why we need to have the material that we use is as cheap as we can. If you are composting more wood materials, that will take longer because of the composition of the wood, right? So if you are composting leaf and things like this, that will uh, will be faster. Okay, Pam, let's go to talk about the other practices. Oh well, yeah. So there you see the piles. You see the biggest pile for a big farm operation or medium to small farm. scale farm operation, and you see the vapor coming out of the pile because of the temperatures, right? So the other thing are small piles that you can make it on your garden, or even if you are producing small scale. So that's an example that no matter how big or how small is your operation, you can make it. And the other thing there, and I highly recommend to have it, uh, it is a thermometer for composting. So you can get one of those for less than $20. Okay. So, and that's will help you to figure out if your piles are getting the right temperature. So if you're composting, I highly recommend to get one of these and have and keep monitoring the temperatures daily. Okay. So there's a lot of other ways that you can compost. You can use a lot of containers and bins and different models. So there are the most common ones. Okay. The piles. Oh, other thing that is, I was talking about the relation between the compost and the microorganisms. So if you want to add microorganisms to your soils, you can do it. And right here, I will share with you this recipe of forest microorganism, as they are known well as the indigenous microorganisms, efficient microorganisms. They have a lot of names, but this recipe is what I done for my master degree thesis project. So I was testing this practice that is from well, that has been used in farming around the world from hundreds or thousands of years, right? So what I done, it was I got a few recipes from Central and South America, and I modified those recipes to the ingredients and the source of materials we have in Puerto Rico. So, but there are many ways that you can grow those microorganisms, okay? And to apply those organisms to your soil to make it that soil alive again, or to maintain the soil alive. And this microorganism, use it with the compost or any kind of organic material in the soils, uh, have a really well results. Okay, so what the recipe I done involve the rice and cornmeal. We use here coffee husk, that is what you're seeing at the left picture, but also you can use rice husk too. Forest microorganisms, local cow's milk, cane molasses, and wood ash. Okay, each of those components have a role in the recipe. It's obviously right. But uh, for example, where you can find forest microorganisms, so you just have to go to a forest area near of your farm. You will move the leaf on the soils, and you will find this kind of this kind of formation, as you see in the border of the barrel, looks like a cotton. That is a growing of a fungus. Okay, so when you find this that's what you will find in the soil. When you find this formation in the first layer of the soil, that indicates you that there are healthy populations of microorganisms. So you will take around 2 pounds of this, of the leaves and the humus in that soil, and that will be your inoculant for the recipe, right? As well, I we add raw cow milk to apport lactobacillus to the our recipe, right? After a process of fermentation of around 30 to 45 days, we have that growing of the microorganisms in that mix. And another time, this formation of the fungus will indicate you that it is ready to use. Then you take an amount of this, and you brew a kind of tea, like a compost tea, with those microorganisms, and then you put into the soils. Okay, and this is one way that you can produce your own microorganisms. There are plenty of uses, not just for for the soil fertility, but also to help and prevent pests and disease on the plants. So we will share the recipe step by step to you with all of you, and also we will share some literature about the uses of this. Okay. As well, I have to mention that you can buy this commercially. You can search for efficient microorganisms or EM, and you can find a plenty of different brands and companies selling this. But I like to produce my ones because if I'm producing from from microorganisms that I can find near to my farm, those microorganisms are adapted to the conditions that that's are present in my farm too. So for me, it is more efficient to use to produce your own ones, and this will cost you less than $20. The one that you have to that you can buy, they're kind of expensive. Okay, they are above of, sometimes, if I remember well, above of 50, 80, and even above of $100. Okay. So let's keep moving forward for other practices. Okay, another practice I highly recommend, and we, by the way, we are just talking today about basic practices to manage soil in better way, right? Are the cover crops. And I know some of you were in the last webinar, and I mentioned them a little bit, but not, today we will talk about more in detail of the cover crops. So right here, you can see two kind of cover crops. The first one you can see at your left upper part of the slide. It's named sun hemp. Of the scientific name is Crotalaria juncea. And this cover crop I really like because it's grow really fast, and it support a significant amount of nitrogen. But there are many other ones, as the other one at the bottom, right bottom part of the slide. It is Mucuna pruriens. The common name of Mucuna pruriens is the velvet bean. This is a common one. You can find on the market a lot of supplements make it using this kind of crop. But as well, this crop could be used as a cover crop to apport nitrogen, nutrients, and to cover the soils. And why the reason I recommend to use cover crop, because the first barrier to protect your soil is to have it all the time covered. Okay, as we talked in the last webinar, that sometimes you need the soils to rest for a while, and in this period, I highly recommend to make it in a managed way and use those cover crop to let your soil to recover for the harvest. Okay, so there are many cover crops that you can use for this, not just to apport nitrogen, to fix nitrogen, and I will explain how they fill nitrogen in within the next few. Okay, Grandly Samuel asks, if can grass be a cover crop? Well, if you look the definition, the basic definition of cover crop, it is any crop that you use to don't leave the soil bare and protect for the erosion. So they are if you just have grass, if you just want to leave the grass growing, you can use it. The important thing it is to keep a constant cover in your soil to avoid the loss of that soil. No matter if you are flat, no matter if you are in decline, no matter what, never leave your soil bare. Okay, so but uh, if you want to maximize this time, you can use this kind of cover crops. Most part of the cover crops you can find on the market are legumes. Okay, but also you will find other kind or families of plants as this one. This one, many of you probably have experience with this, is the daikon radish or white radish. So the daikon radish is used as cover crop too, because the cover crops also could be used to maximize and improve the soil structure, right? and it is a term or kind of practice name biological tillage. And the biological tillage, it is done using this kind of plants, especially this one, because of the in the way that plant grow, that's help to lose your soil as well. It's translocate, have the power to translocate nutrients from from the lower part of the soil to the upper layers, right? So that is another example of other plant that could be used as a cover crop. So if you have a soil that is kind of heavy, as well, you can use it to apport a significant amount of organic matter, because after it's grow, you can cut the upper part and the root will decay within the soil, and that will be another way to apport organic matter to the soil, right? So this is another kind of cover crop that you could use. Okay, Pam, let's go ahead. So right here, it is a picture, and I know Samuel Granley will like this. Uh, this is a crop of planting in Puerto Rico. Um, this is an intercropping between plantains and a cover crop named Canavalia, and that's helped the plantains plants to be a kind of stronger. At the same time, this plant is fixing and providing nitrogen to those plants. So at the same time, it is reducing the labor to the farmers, because in this way you don't have to be cutting the grass or applying herbicides or things like this. That is one of the other use of the cover crops. Okay, and for the friends in USBI, I sent a little amount of this to the art farm. I know Christina is there, so I want to let know how they, if they are using, how they are growing, right? But it's really useful. This is one of other use that you can uh, done with the cover crops. Okay, as well, it is used as a natural mulching too. Okay, so well, talking about the nitrogen apport of the cover crops to the plants. So most of the cover crops. Okay, okay. Let me stop here. Okay, Samuel, Grandly. So yeah, so I will explain in the next moment how you apply fertilizer in combination with cover crops. Okay. Okay, most part of the cover crops are leguminous plants or from the family Fabaceae. Okay, they are these kind of plants have the potential of the power, because it is a power to fix nitrogen from the atmosphere. So the most vast of okay, the biggest storage of nitrogen on Earth, it's the air, it's the atmosphere, right? So a little more than the 70% of the air we breathe, it's nitrogen, right? As well, it's kind of expensive to buy nitrogen for fertilizer, right? But those plants make an association with a bacteria named rhizobin or rhizobacteria. They have the power to take this nitrogen from the atmosphere, from the air, and fix it into the soil and provide to the plants. So with this family of plants, they that make this kind of association with the bacteria in the roots. And if you take out of the soil one of those plants, you will notice they have this kind of tumors, right? And if you cut this, in it is in this kind of color around a rose color or something like this, that's indicate that the bacteria are fixing that nitrogen. Okay, so that's the reason why bacteria in soil have the power to fix that nitrogen, and it is really helpful. Okay, but if you want to know if you need to keep providing the plant with more fertilizer, the way you done it is there are many research done in this way, and you can say, oh, okay, I will use sun hemp. How much nitrogen sun hemp can provide to my farm or my area if I don't know, if I plant an acre. So there are some densities of planting of the cover crop that say in the I will share some of those examples with you too, of how much of the nitrogen that plants can fix. Then you need to analyze how much of nitrogen your your crop needs, and if this any kind of difference you can provide using other kind of fertilizer, using compost, using synthetic fertilizer, the way you want. But sometimes those cover crops are capable to provide all the nitrogen that crop will need. If you are using this to provide nitrogen to your crop, so you plant them, when they start to produce the bud of the flower, it is the time that they have the maximum amounts of nitrogen in their bodies, and that it is the time to cut them, chop them, and integrate to the matrix of soil, to incorporate to the matrix of the soil. Okay, just to let you know, so in the way that is well. And the rhizobacteria, they are soil borne. They are in a healthy soil, you will find rhizobacteria. Just when those plants are present there is when they show up and make that association and start to fix the soil. My bad, start to fix nitrogen to the soil. Okay, so to end our conversation for today, and I know I mentioned this last time, we will talk about the prevention in the soil of erosion, and we two basic are the contour drainage of water. So I include those photos here because last time I know that farms in someone mentioned that in Bahamas all the farm are flats, but no matter how flat it is your farm, it could be prone to the erosion. So no matter if you farm just have a 3% of decline, so if you can make your crops in contour, that will help you. And if you don't want to make this, I highly advise you to implement a system of ditches to help the water run out of the farmland, and that will help you and prevent you to have any kind of problem because of excess of water in your crops. Okay, so now I ask Pamela to stop share their screen. I will share you, and that is the reason I mentioned this, because I will show you now in which way you can make handmade tools or homemade tools identify or mark the right way and the inclination of your contour lines or the system of ditches. Okay, so I will share this presentation. It is on Spanish. I just want to you to see the pictures of those tools. Okay, and I will translate the instruction if you want to make it by yourself and use those tools. Okay, this that the next slides that you will see are not mine. They were developed by a guy who works for NRCS in Puerto Rico for more than 30 years. He retired past year, and uh, that's his work has been really grateful because he promotes this kind of practices in Puerto Rico, and it's been really helpful. Okay, as well, I want to share with you to just to try to use it in your locations and have the same advantage that we have here. Okay, so let share my screen here. 1 second. Okay, let's see. Okay, Pam, are you seeing my screen?
Yes, we are.
Thank you. Okay, so just to let you know, so that right here it is a picture of a farm in Puerto Rico. So if you look, those lines are hillside dishes is the name of those kind of practice there. I just want you to see at the bottom image of the screen. So just to let you know, when we are implementing practices to control the erosion of the soils, it is highly recommended for each diameter in deep in our slope to make the lines of those barriers. Okay, and if your inclination is more intense, so the lines of erosion control will be more close each one. If your if your decline of the slope is not so heavy, so the lines will be a little farther. Okay, so in which way I can see, by the way, that picture it's from sand crakes. Okay, those are some erosion barriers making with moringa. But anyway, so they are some sophisticated tools that you can buy to make to make these kind of practices. But with less than $20, you can produce some ones that will help you, and they are really useful as well. The results are comparable to the ones that you have with those expensive tools. Okay, the first one I want to share with you is the T-stick. Okay, and the T-stick, it's the one that women have in the hand, will help you to determine the distance between your erosion barriers or your hillside um, ditches. Okay, so it's you just have to do it. It is to construct this. You can make it using wood, but as well with PVC pipe of around half inches of diameter, and the height of this will be around a meter of height, because that will help you to determine the distance between the barriers. Okay, so each barrier should be at a distance of 1 meter of depth. Okay, so what you do is you put in the top part of this tool, you put a carpenter level or bubble level. So when to indicate you that you are holding this at level 0. Okay, what you do with this, it is when you start to work in the slope, you say, I will start to work here, and right here will be my first erosion control barrier or my first hillside ditch. So how far the next one will be? So you mark the first point, then you start to go far from this point, and when you can see the bottom part of that point through the T-stick, and the level it is when the bubble is at the level, that's indicate you that it is at the right distance. Okay, sounds kind of tricky, but it's really easy to use. The other thing, and a tool that in my personal case changed a lot for me, it is this one. In Spanish we name this the caballete, but I don't find a right translation to the English. So in the way I will call this will be a soil level. Okay, so it is a really basic tool, and what you do it is with, you can build it with PVC or even with wood. If you build it with wood, it will be kind of heavier, and it's more easier to work in on PVC. So what you done it is you take uh, a PVC pipe, you cut in 3 parts, and you put the bubble level in the very center of the bridge. The bridge, it is the transversal part, right? So as you see here, so puente means bridge. Okay, so how long it would be, you build it, the length that you will use is the one that work for you. So the standard length I use it that I build mine ones are 6 feet. Okay, or around 2 meters. Okay, so each of the legs of this have to be at the same have to be the same height, okay? And if it's measured 100 inches, okay? So in the in the center of the bridge, you will put the level, and that will indicate you that your lines, your contour at the level 0. If you want to make some inclinations to more to if you will use this to design your ditches, and you need to have some inclination within the ditch to the run of water. So what you will do it is that one of the legs will be shorter. For example, if your bridge is from 100 inches length, you will have one of your legs 3 inches uh, smaller than the other one. For example, if one of you, if your legs are 36 inches each one, so your bridge is it's 100. So you will cut 3 inches from one of the legs to be shorter, and you will be using this to give the right level of 3% of your dish, securing that the water will run in the way you want. Okay, uh, if your bridge it's 50 inches, the leg will be just cut just 1.5 inches lower than the other leg, because it is the percent that you want to have it for decline that will be proportional to you will estimate this uh, using the length of the bridge. Okay, so the 3% of the length of your bridge, or 2%, or the 1.5. I recommend that for the decline within the dishes to use around 1.5% of decline to 3%. Okay, no more than this, because as more declining you build that dish, so the water will run more fast and can erode the ditch too. Okay, but if you want to make infiltration ditches, the level of the ditch will need to be 0. Okay,